So today we are going to be talking about, you know, what is actually vector. Some of you might just be asking the question, what is vector? Now, before now, I believe you know what a vector quantity is and a scalar quantity. Yeah, a vector quantity. Vector quantity is a quantity that have both magnitude and then direction. But a scalar quantity. So all vector quantities are defined by their magnitude, which is size, and then their direction they are going towards. Force is a vector quantity. In fact, examples of vector quantities are, you have force. Force is an example of a vector quantity. You have velocity. You have weight. You have acceleration, and so on. All these are all vector quantities. Now, when we are treating vector, we are indirectly treating forces. So since force is a vector quantity because force has magnitude, which means size, and it has direction, every object moves in the direction of the force that pushes the object. So vector, force is a vector. So we are going to be discussing force as a vector. So this vector we are discussing is a form of force right here. Now, since we have already given a background for what vector is now as a force, now let's look at how to represent vectors. So representation of vectors. If you see a vector in a book or a paper, how do you recognize that this is a vector? Now, a vector can be represented with a straight line for the point of action and an arrowhead. A straight line with an arrowhead. So let's assume this is the point of action and the point of action is O. And the straight line with an arrowhead represents a vector. Now, the length of the line determines the magnitude of the vector, which means the size of the vector. The longer the line, the bigger the magnitude. Now, if I want to represent a 20 Newton vector, this could be a 20 Newton vector. If I want to represent another one, which is a 40 Newton vector, it wouldn't be like this, it would be longer than this. So my 30 Newton vector would be acting from point O towards this direction, and I must put an arrowhead on it indicating that this is the direction it is going. Now, the length of this line determines that the magnitude of this vector is bigger than the magnitude of this particular vector. So this could be 40 Newton vector. All right, and then okay, so that is how to represent vectors. Now next, let's look at how to resolve vectors. Now, if we have two or more vectors acting in a body to put the body in motion, the question is, how do we resolve vectors into a particular vector? So resolution of vector is to find its resultant vector. Now, a resultant vector is the resolution or the combination of two or more vectors into a single vector, such that that single vector would have the same effect as the two vectors acting separately. Now, the question now is, if this is a resultant vector, if two or more vectors are acting on a body, how do we resolve the vector to find the resultant vector? But first of all, two vectors acting on a body can act on the body differently. So we can have two vectors acting on a body in the same direction. We can have two vectors acting on the body one. Then secondly, we're going to be considering when the two vectors act on the body but in opposite direction. So we have the next one, number third point. If the two vectors acting on the body are acting in the right angle, by right angle we mean 90 degrees. So if the two vectors are acting on the body at 90 degrees to each other, so if then the fourth case is if the two vectors are acting at an acute angle to each other. So if then lastly, we are going to be considering when the two vectors act on the body at an obtuse angle this time. So if obtuse angles are angles that are greater than 90 degrees but less than 180 degrees. Now let's take these cases one after the other. In this video, we are going to be doing first case and second case. Then we'll complete the rest cases in our next video. So let's see. If first case, case 1. So let's say the two vectors act on the body towards the same direction. So let's assume that this is the body in question. Or let's assume that this is the body in question, this is the object in question, and we have the vectors acting on this object towards the same direction. So we are having, let's say, a vector here acting on the body towards the left direction, and another vector acting on the same body towards the left direction. From the size of the lines, you would see that this vector is higher than this vector. The magnitude of this vector is higher than the magnitude of this vector because of their length. Now I can name this. Let's say this is 20 Newton force of vector, and this is 30 Newton vector. So if we are to resolve this to get the, okay, let's assume this first one also is Q, vector Q, and this one is vector P. Then to get the resultant vector, which is R, then what do we do to these two forces to get the resultant vector? The only possible thing to do is to add up the two vectors, because this object would be pushed by the two forces towards the same direction. So if we resolve these two into one singular vector, that single vector will also have the same effect as the two vectors acting separately on these objects. So we would have 20 plus 30. So if the two objects are acting towards the same direction, the two vectors are acting towards the same direction on the object, what do? We add up the two vectors. So we have resultant vector will be equal to Q, vector Q plus vector P, which will be 20 Newton plus 30 Newton. That will give us 50 Newton. So resultant force is 50 Newton. Towards which direction? Towards the left hand side. So you can say towards the left. Towards the left. Because what we are resolving, resolution of vectors, is not complete until you have gotten the resultant and as well the direction of action of the resultant vector. So the two of them defines resolution of vector completely. So we have this towards the left direction. So the direction is towards the left, while the resultant vector is 50 Newton. That is that for the case 1. Now the case 2, for case 2, we are having when the two vectors act on the body in opposite direction, which means if this is the body in question here, so this is our object, and we have a vector acting on this towards this direction, and we have another vector acting on this towards this direction. Please note the arrow. So we have something like this. Now this line is smaller than this particular line. So let's assume this is Q vector, and this is 30 Newton vector, and this is P vector, and the P vector is, let's say, 70 Newton vector. Now the question is, what will be the resultant vector? So the resultant vector would be the subtraction of the two vectors. Now look at it, both of them are pushing towards the opposite direction. So which means that one of the vectors that is bigger will counter the other one that has a smaller vector. So we subtract the vectors, which means that our resultant vector would be P minus Q. It's always the highest minus the lowest. So we have 70 Newton minus 30 Newton. So our resultant vector will be 40 Newton. Towards which direction is the question? Towards direction P. Towards the P direction. I'm getting it, towards the P direction. So it will be 40 Newton towards P. So that is the direction. So now the question now that is that if Q and P are the same amount of vectors, which means they are the same forces, they are the same vectors, it means that this object O will not move at all. The reason it will not move at all is because if this one is 30 Newton, this one is 30 Newton, both of them will counter each other, and it means the object will not move. They will counterbalance each other. It means the object will not move. So 30 minus 30 is 0, which means the object is not in motion. So that is that for that. And I hope you enjoyed this video. You can look for other questions and solve on this, just addition and subtraction. So please do well to subscribe to our YouTube channel at PEG Tutors. Thank you very much.